Hi, welcome to HowToStats.com. In this video, I'm going to demonstrate how to perform a Kendall's tau analysis in SPSS. Now, very briefly, Kendall's tau is a non-parametric correlation that is performed ideally on ranked data. And it's an alternative to Spearman's rank correlation, but I'm not going to go into too many details about what the differences are between the two. So let's take this example here where somebody rated, this is a master art evaluator, and these are the exhibits of art that the person rated, and after they rated them, or they ranked them from 1 to 12. So the best piece of art was ranked as a number 1, and the least impressive piece of art was ranked as 12. And so they're all ranked, and then they're all sorted as well. You don't actually have to sort them in SPSS, because SPSS will do that for you. But I'm just showing this as an example. And in this case, we have a student who did ranked the same 12 pieces of art, and you can see that there's some association here. We're expecting some positive association because the lower ranked items in the master's column also tends to be the lower ranked items in the students' columns. But none of the rankings are actually totally exactly the same, are they? And I find that interesting that people call it the degree of concordance between rankings, but it's not exact concordance. And I've got another video where I talk about what that means and what Kendall's tau is actually doing by going through the formula, and I do it in a non-technical way, so I encourage you to read that. Check that out. Okay, so here's how you perform a Kendall's tau analysis in SPSS. So you're going to analyze, correlate, bivariate, and then you put your two variables in, master and student, into the variables, and it's actually over here, Kendall's tau B. Now what Kendall's tau B is simply the Kendall's tau formula that can handle tied ranks. So you should always choose that as an option. There is no tau A because tau B can do everything tau A can do. Plus it can do the tied rank case. And here's the Spearman rank correlation, but we're not going to choose that. It's only the Kendall's tau B. So click OK. And we get a Kendall's tau B coefficient of 0.818. So there tends to be a positive association between the rankings of the master and the art rankings by the student. Now let me add another example here. We're going to call it student B. Oh, that didn't work out. Let me just delete that. Okay, and I'm going to get the data for this student here. That's student 1. Actually, I've made that mistake, student 2. But I'm just going to get some different data to show us what it looks like. In this case here, student 2 has rankings that appear to be somewhat even better than the first one, in the sense that there's a lot of, if you look at the master ranked this art exhibit as 2, and the student ranked it as 2, 3, and there's almost perfect concordance between these rankings. And the only exception is that the second student ranked the top level art exhibit by the master's opinion as the worst piece of art, because he ranked it as a 12, or she. And then the worst one, by the master's opinion, is ranked the best. But everything else is the same. So which one do you think will produce a higher correlation? The one with perfect correspondence across 10 of the 12, but then huge divergence on the only 2? Or the first student, who tends to be off by 1 in every case, but that's at most 1. Only off in the rankings by 1. Let's check it out. Analyze, correlate, bivariate. We'll throw the student 1 out, student 2, and click OK. And correlation is 0.364. So actually, it does make a big difference if there are big differences across only 1 or 2 of the rankings. And I think it would be an interesting question to find out whether the differences between these correlations would also be the same for Spearman correlation. But I'm going to do a separate video on the difference between Kendall's tau and Spearman rank correlation, and I encourage you to check that out if you're interested. Thanks for coming by.